OPO Betterman.
This audiovisual presentation by OPO Betterman is aimed at bettering the welfare and security of people all around our beautiful world. The next 30 minutes will for sure change your perceptions and prejudices on one of the most common but unknown facets of your life. Anxious, aren't you? A phenomenon that causes the death of people and livestock in scores. No living thing is spared. Plant life is destroyed. And if you think you're safe in the confines of your modern home, you're thoroughly mistaken. Yes, we are talking about the most devastating of natural phenomena, lightning.
Lightning, the phenomenon and its prevention.
Doesn't everyone enjoy watching rain? Undoubtedly, yes. But if the soothing showers are accompanied by dazzling flashes of lightning, the scenario changes for worse. However brave one may be, the inborn fear of lightning causes one to confine oneself to the interior of one's home. However, these cozy interiors cannot ensure one's safety. The scientific community has subjected this mesmerizing phenomenon to numerous studies. Let's peep into the science behind lightning and thunderstorms.
Science of lightning. Lightning are high-voltage energy currents originating from rain clouds. There are three types of thunderstorms: those originating from inside the rain clouds, those originating from between two masses of rain clouds, and those originating from the above and terminating on the surface of the earth. It is the last that causes the utmost destruction. But the other types too have the potential to wreak havoc, especially to flying aircrafts. When a flying airliner is struck by lightning, its electronic signal circuits are interfered with, which leads to occasional air disasters. Lightning are rapid-moving columns of electrical charge, formed in a time span of 1/100th of a second. Thunderstorms contain millions of volts of electricity with thousands of amperes of conductivity. They also have a temperature of up to 30,000 degrees Celsius. Though lightning occur unexpectedly at any given time, the probability of having a lightning strike is more during afternoon. It is virtually impossible to predict the date, time and location of a lightning strike, but through sustained study over the years, the probable location, date and period of a strike can be ascertained. Air hovering above the Earth's surface gets heated by the rays of the sun and gradually rises in the atmosphere. As the air rises, it carries along with it thousands of tiny droplets of water. When this column of air rises up to a distance of 2 kilometers above the Earth, it begins to cool rapidly. The water molecules within the column of air freezes, and thus small clouds are formed. When the moisture content remains and the air rises further, bits of clouds formations conjoin to form rain clouds. Such rain clouds are called cumulus clouds. These cloud formations expand in volume as it proceeds to rise up to 17 kilometers above the Earth and become larger enough in volume, the size of which prevents it from rising further. Such clouds are called cumulonimbus clouds. It is from these cumulonimbus clouds that lightning occur. Cumulonimbus clouds are formed by tiny flakes of ice and snow. These ice and snow flakes, due to constant friction with one another, get electrically charged. The innards of the cumulonimbus clouds, where such continuous collision and movement of air happens, called a cell. The light-weighted ice flakes, which get positively charged through such continuous collision, move to the upper part of the cell, and the comparatively heavy snowflakes get negatively charged and positioned at the bottom of the cell. Along with this, a minor positive charge is formed at the base of the rain cloud. When the electrical charges inside the rain clouds gain strength, it activates the opposing charge in the Earth's surface. Thus, the positive charge in not just the Earth's surface, but those of the things like trees, towers, and even living things that project towards the atmosphere also becomes active. When the electrical charge inside the cell rises disproportionately, it fractures the non-conductivity of the air to establish contact with the positive charge situated beneath the rain clouds. Thus, a continuous path of electrical charge is formed. This path of electrical charge is called a step ladder. The charges inside the step ladder and the charge of those objects on the Earth's surface rising to the atmosphere, yearns to establish contact. Thus, the electrical charge inside the clouds reaches the objects on the Earth's surface as numerous channels. As a response to the electric charge falling into the Earth's surface from the clouds, an opposing charge is returned back to the clouds. This is called return stock. It is this return stock that we see and commonly known as a lightning. Due to this sudden and immense electrical stock, the air at the clouds level gets heated up to 30,000 degrees Celsius in a time of a 1,000th of a second. Thus, atmospheric pressure rises immensely, and the expansion of this pressure is felt by us as the thunder that follows the lightning. The thunder needs approximately 3 seconds to travel a kilometer in space. Calculating the speed of sound of the thunder, we can ascertain the origin point of the lightning. The more intense the sound of the thunder, more closely is the origin of the lightning.
We hope that this scientific explanation has proven useful to you. It's relatively easy to ascertain the origin of lightning by calculating the speed based off the sound of thunder accompanying the lightning. We know that thunder travels approximately 1 kilometer in 3 seconds. The next time you see lightning, start counting. You'll be able to calculate how far lightning has struck. 7. The lightning we just saw struck approximately 2 kilometers from where we are. So far, we've seen how lightning strikes. Now, let's look at how a bolt from the blue causes us so many inconveniences.
Lightning, circumstances, and dangers. It is those objects projecting from the earth skywards that the lightning strikes. The more the height of an object is, the more chances of it getting struck. Amongst those projecting towards the sky, metallic objects are more prone to a strike. When the surface of such objects contain more metallic material, the more are the chances to a lightning strike. Mountainous regions, as well as trees, people and livestock situated in vast open areas are prone to get struck by lightning. The chances of a strike are directly proportional to the height of trees. An individual in close proximity to trees or metallic objects is also highly prone to lightning strike. When an object or tree is struck by lightning, a side flash is created around it. This is life-threatening to those individuals in close proximity to the object or tree. In such circumstances, it is better to maintain a safe distance from such objects. More grave than the dangers posed by the side flash is the electric charge conducted to the earth by a lightning. The electricity thus conducted enters the bodies of human beings and animals alike. The fluctuation in voltage of this electricity as it travels through ground up to when it reaches the feet of human or animal. This voltage fluctuation is called step voltage. Step voltage causes the maximum damage caused by lightning to human beings. Injury is caused also when metallic objects are touched or used during a lightning. This is called touch voltage. Electricity thus entering the human body through touch voltage, step voltage, and side flash reaches the brain and affects our nervous system. This disturbs the normal functioning of our heart muscles and causes loss of life. Injury caused by lightning varies according to the intensity of the electric charge. Injuries varying from severe burns to loss of limb and life are the hidden dangers of lightning. When an individual is struck by lightning, his life may be saved if he is given artificial respiration and rushed to the nearest medical center. The electric charge of a lightning is intense enough to cause injury and death to animals and humans alike, apart from causing damage to residential buildings and the electrical and electronic appliances. Lightning conducted to buildings and electric power lines causes a high-intensity energy surge to metallic objects and electrical wiring inside houses and causes extensive damage. Even when trees near a building are struck by lightning, the surge in energy travels through the earth to enter the building. Such energy entering buildings are called surge current. The surge currents entering buildings are potent enough to wreak damage to electric and electronic appliances and cause injury to its inhabitants. On occasions, surge currents are conducted to even 2 kilometers from the buildings. In studies conducted worldwide, It is learned that of all damage caused to electronic appliances, 30% is attributed to electrical surge caused by lightning. Thus, the total annual loss can be estimated to millions of rupees caused by lightning. Due to geographical influences, the damage caused by lightning strikes in Kerala is well beyond comprehension.
Kerala is a region that has one of the highest incidents of lightning in the country. Every year, about 70 people die of lightning and more than 100 are injured. A peculiarity of Kerala is that most houses are situated in the midst of tall trees which are taller than the house. So even if the house is not hit by lightning, the trees are hit by lightning and the lightning current flows through the ground into the house. It could also flow through wires that come from outside, like the electric line, the telephone line, and cable television line. This is the cause for more than half the deaths caused in Kerala, as per a study conducted by Center for Earth Science Studies.
It's necessary to take effective steps against lightning, potent enough to cause harm to all beings. It was a scientist named Benjamin Franklin in the United States who first attempted a closer study of this phenomenon in 1752. Since then, the scientific community has tried to develop ways to counteract the dangers caused by these bolts from the blue. The result was the development of a lightning-resistant system. Let's look at the lightning-resistant system and how it effectively counteracts the harms of lightning.
Lightning protection devices. Main objective of a lightning-resistant system is to divert the electrical charge caused by lightning and thus negate its destructive potential. Lightning-resistant systems obstruct the flow of high-voltage electricity, redirecting it to be absorbed by Earth, thus saving buildings and its inhabitants from harm. Lightning conducting systems can be classified into two: external protection systems and internal protection systems.
We have learned that lightning protection systems are divided into internal and external protection systems. When we employ a method to safeguard ourselves, our homes, and our appliances from lightning and its devastating effects, it's important to ensure that the methods in use are effective and scientifically developed. If not, there'd be no guarantee that they would work during a time of need. It would be better to have an understanding of lightning conductors approved by the Bureau of Indian Standards and the IEC.
The external protection system consists of three main components: air terminal or interceptor placed above the building, down conductor, and earthing. In this system, the electric charge from the lightning is received by the air terminal and is sent through the down conductor and further to earth through the earthing system. Before employing a lightning conductor, the prospective buildings and geographical areas need to be carefully surveyed for the number of times the area is struck by lightning, the trees and tall structures near the building, the area of the building, the number of people living or being employed in the building, and the value of electronic appliances inside the building. The IEC recommends 4 levels of protection based on the factors listed before, from the high-level LPL1 to the normal LPL4 level. The air terminal is the metallic column placed at the highest point of the building. An air terminal can be made of any conductive metallic material. Bigger building complexes need more than just one air terminal. In such buildings, more air terminals are to be fixed. These air terminals are to be linked through copper, aluminum, or GI metallic strips to the earthing system. When the conducting systems are fixed, there are certain things to be extra careful of. Notice the picture. The air terminal fixed in this building offers no protection because the tree near the building is taller than the air terminal. When lightning strikes, it would strike the tree. The lightning would strike the tree and the resulting side flash would enter the house without any hurdles. There is something else too that needs to be remembered. The varying shapes seen at the tips of air terminals do not offer any special protection. The air terminal does not need any complex shapes. In buildings, with heights of 60 meters or more. The risk of a strike is not confined to the top alone. Since the sides of the building too are vulnerable to attack, the edges of the buildings too are to be secured to the air terminals and down conductors. If the roof of the house is made of flammable material, the air terminal is to be placed at 0.15 meters above the roof. But if the roof is made of conductive metals, these materials themselves may be used as air terminals. There are 3 methods by which air termination system can be installed after taking the building's shape and structure into consideration. For houses with simple shapes, protection angle method can be adopted. The rolling sphere method is suitable for buildings of any shape. For houses with flat roofs, mesh method can be adopted. Apart from the air terminal, the down conductor is the most important component of the external protection system. The down conductor's function is to channel the electric charge captured by the air terminal to the earthing system. The down conductors are to be installed in a manner so as to enable the smooth flow of electricity speedily and efficiently to the earth. In buildings with complex shapes, all shapes and edges of the building are to be protected and connected to the down conductor and the earthing system. Any material with electrical conductivity can be used as down conductors. When the down conductors pass through external walls made of flammable material, a specific distance needs to be maintained between the wall and the conductors. When the arrestor system is installed in high-rise buildings, it is to be ensured that down conductors are installed every 10 to 20 meters. When down conductors are placed parallel to the roof, they are to be linked using ring conductors to prevent fire outbreaks. The earthing system is the third component in the external protection system. The earthing system carries the electricity captured by the air terminal and conveyed by the down conductor to the earth. GI metal sheets or copper wires are used for preparing the earthing system. The earthing system thus prepared is placed at a distance of 1 meter from the periphery of the building and at a depth of ½ meter. It is always ideal to set up ring conductors around the building instead of having multiple systems. In highly populated areas, it is better to install multiple ring conductors to prevent the dangers caused by step voltage. This is also considered to be the most effective system for residential buildings surrounded by trees.
The safety of humans and appliances can't be assured just through external protection systems. If a protection system is to be foolproof, internal protection systems must also be employed. Let's look at how internal protection systems safeguard us and our valuables.
The electric charge flowing into the residential building is called surge current. The surge current entering the building causes extreme voltages. This voltage flows into the electrical and electronic appliances inside the house. The surge current damages the appliances inside the house, even those which are not working at the time of the strike. An external protection system will not to be able to protect against the surge current flowing into the building. It is to protect against these damages that an internal protection system is used. The internal protection system protects against surge voltage formed in the electric wirings, TV and telephone cables with a conducting capability and minimizes potential damage. But when the surge voltage caused by lightning exceeds a predetermined limit, the SPD activates itself and returns the surge voltage or to the earth through a short circuit and thus saves the electronic equipments inside the building. It is important to ensure the quality of these SPDs through international standards such as the International Electro Standard Series IEC 62305 and 61643. Such SPDs are classified into Class 1 or Class B, Class 2 or Class 3, and Class 3 or Class D. When the electric charge caused by lightning travels through a metallic object, it reaches high intensity within a specified time, and further the intensity diminishes slowly as time passes by. The intensity of this electric charge reaches its peak in 10 milliseconds. After 350 milliseconds, the intensity diminishes by half. This is called 10 by 350 microsecond current impulse. SPDs capable of diverting strong lightning charge is classified as Class 1 SPDs. SPDs which divert the comparatively low surge current or 8 by 20 microsecond impulse produced when electronic appliances functions are called Class 2 SPDs. And those protecting sensitive equipments are classified as Class 3 SPDs. Internal protection against lightning attacks are ensured through such SPDs.
Surge protection devices play a major role in protecting against the harms caused by lightning. It's important to install quality equipment when protecting against lightning. OBO Betterment, established in 1911 in Germany, developed surge protection devices in 1972. The manufacturing and quality control process conformed to international quality standards and is the best in the world. Let's look at OBO Betterment's surge protection devices and its unique qualities.
OBO Betterment surge protection devices.